This is R.D. Sharma solution, class 12th. We are taking chapter 19. Exercise is 19.24, indefinite integrals. Now in this question, we have 1 by 1 minus cot x, and we will use the trigonometry and trigonometric identities wherever it is required. So let's change this cot x into cos x and sin x form. So this denominator will be 1 minus cos x by sin x. So this will give you what? 1 divided by, let's take LCM of the denominator, sin x minus cos x, and this sin x in the denominator goes up. It will go in the numerator. Now sin x minus cos x will come in the denominator. Now what to do with this sin x? So that we can get either the denominator or the differentiation of the denominator. If I take this has to be taken later, but if I take t equals to sin x minus cos x and differentiate this, dt by dx will be what? It will be cos x, and cos x will be minus sin x. So it will be cos x plus sin x. So dt will be cos x plus sin x dx. So we have got cos x plus sin x. So we need to convert this numerator in certain form, maybe the cos x plus sin x form or sin x minus cos x form. So let's multiply this numerator denominator by 2. I am just taking the numerator. If you take this numerator 2 sin x, you can write it as sin x plus sin x, because 2 sin x is sin x plus sin x. Now add cos x and subtract cos x. When you add and subtract cos x, and sin x minus cos x is already in the denominator. Now why we did this? Because this sin x minus cos x can be combined together. Because we have multiplied by 2 sin x and 2 sin x was sin x plus cos x, we have added cos x, subtracted cos x. So this sin x minus cos x divided by sin x minus cos x, the other term remaining, when you take this sin x minus cos x away, the other thing will be sin x plus cos x. That will be remaining, and denominator of course remains the same. This half we are going to deal later. So this first term, you see that this it get cancelled easily. That is, this is dx and this is dx. So the first term which we try to simplify using this sin x and cos x, the first term gets cancelled, numerator denominator, and the second term, fortunately we have already done that t equals to sin x minus cos x equality. We have assumed that, and when we differentiate, numerator has come. So numerator is simply dt. So sin x plus cos x dx can be written as dt. The denominator we have taken as sin x minus cos x, which can be written as t. So we are actually taking I1 and I2. I1 is simply x because integration of dx is x only. How about this dt by t? It's log modulus t plus constant of integration. But t was taken initially as sin x minus cos x. So we can write it like this, log. Basically it's log base e. So you can write ln also. Sin x minus cos x plus constant of integration. Now half was already there. So just multiply everything by half in order to complete the answer. So this is the way we are going to go about it, and you'll see that this question 1 by 1 minus 10x is almost equivalent to the previous one. So we'll resolve it the same way, 1 by 1 minus 10x. So 1 minus sin x by cos x we can write. Now take the LCM of the denominator. It will be cos x minus sin x divided by cos x. This cos x will jump upstairs. So we'll get cos x divided by cos x minus sin x. And this is just a simplification. Now we need something so that either we can transform the numerator into the denominator or numerator into the form of differentiation of the denominator. For that, let's take t equals to cos x minus sin x, which is the denominator. When we differentiate it, it will be negative sin x, and this will be cos x. So if you take this minus common, it will be sin x plus cos x. This is the sin x plus cos x which we can directly write. But sin x plus cos x is not there in the numerator. Please remember. So just multiply numerator denominator by 2. So you can write this twice cos x as cos x plus cos x. Half we will deal later. Denominator is cos x minus sin x. So now you can just subtract a sin x and add a sin x, because 2 cos x was cos x plus cos x. We added and subtracted minus sin x because we needed cos x minus sin x. Alright. So this cos x minus sin x, because it was taken as t, and we also want the dt also. Both of the term we need to get. If you take this negative common from sin x plus cos x, you will get negative here. So cos x plus sin x into dx will be directly negative dt. So we will just separate these two terms as per our convenience. cos x minus sin x we have taken. In the denominator we have cos x minus sin x. Now these two terms have been taken. Only remaining is cos x plus sin x. So cos x plus sin x divided by cos x minus sin x. So this is just the separation of the actual term, actual integral into two terms which can be easily integrated. That means half is already there outside. The first term, it gets cancelled out. Cos x minus sin x is upstairs and downstairs, it gets cancelled out. So you can write this as integration of dx. Half we will deal later. You already have taken this as t. If you remember, t was cos x minus sin x. And this cos x plus sin x dx is already come as negative dt. So I am taking negative outside, dt here. And t was already taken, so dt by t. Plus constant of integration. This is your integration 1, this is your integration 2. Integration 1 is quite easy, it's just x, because integration of dx is x only. Dt by t will be log or ln modulus of t. What was t? Cos x minus sin x. Plus constant of integration. Okay. Half is also there, so you need to multiply this half also before actually declaring that you have solved it, because half was already there. So this is how you are going to go about it if you are solving by yourself. So it's just like the previous one. Now this question has to be seen very keenly. What we will do here is, we will try to get or convert the numerator in the form which is of the denominator. Or we can just change the numerator in the differentiation form of the denominator. So we have three terms here. Please remember, in the numerator denominator we have three terms. If we differentiate the denominator, you will get 2 cos x minus sin x. Now this 2 cos x minus sin x is upstairs. You can take 1 sin x from 4 sin x and 2 cos x plus minus sin x, like that you can do. You will separate these two terms. That is one way. But the better way is to just, because there are three terms, right? So just write this numerator 3 plus 2 cos x plus 4 sin x and try to equate it with a. Now you have to include or insert three constants here, because three terms are there, one with cos x, one with sin x, and one is the constant term. So just multiply a and write the actual denominator, a into 2 sin x plus cos x plus 3. Now when you take this b, what will be b? It will be the differentiation of 2 sin x plus cos x plus 3, which is 2 cos x minus sin x. So 2 cos x minus sin x we have done, plus constant. Now first was the direct denominator, second is the differentiation of the denominator. Okay, the first was with a, the second we have included it with b and a constant term, because there are three terms on the left. So you'll get 3 plus 2 cos x plus 4 sin x equals to, now multiply this, 2a sin x plus a cos x plus 3a plus 2b cos x minus b sin x plus constant of integration. Now let's take the sine term together. This is 2a sin x. So you can take this sin x common. What is sin x here? One more sin x is there. So 2a minus b, if you take sin x common from these two terms. Then we have cos x term. Take the cos x common, whatever is inside, that is remaining, a plus 2b will remain. So I've taken cos x common, a plus 2b has remained. And the third term will be constant, which is 3a plus c. Now equate the similar term, that is 3a plus c equals to 3, the first equation. Second equation is 2 cos x will be equal to a plus 2b into cos x. The third term, we will equate the sin x term, which is saying that 2a minus b has to be equated with the 4, because sin x will get cancelled. So let me write the actual one here. Alright. Now the first equation we are getting is 3a plus c equals to 3. Second is a plus 2b equals to 2. Third one is 2a minus b equals to 4. So these are the three equations. Now you can solve it. If you want, you can solve it by yourself. Just skip to the later part. This is just algebra, because 2a minus b equals to 4. We need to get this b cancelled. So multiply the third equation by 2, which will be 4a minus 2b equals to 8. And just add this with the second equation. This 2b gets cancelled. 5a equals to 10. A will be equal to 2. Now just equate or put a in first and third equation. 3 into 2 plus c equals to 3. So c will give you minus 6. Now a you can write here, 2 into 2 minus b equals to 4. So b will be equal to 0. So all these three terms we have got. Now this first equation, the values have to be put in here. That is a. What is a? It's 2. So 2, write 2 here. Then write 2 sin x plus cos x plus 3, which is the original denominator we have. Then we have b. Accompanying with b, we have 2 cos x minus sin x, which is actually the differentiation, but incidentally b is equal to 0, so we will not include the b term. Only c will remain, which is minus 3. So now we will just write the denominator, because this is all we are doing with the denominator only. So numerator only, so denominator we are writing now. So 2 sin x plus cos x plus 3 has to be written in the downstairs part of both the terms, 2 sin x plus cos x plus 3. Now the first thing here is, see, these two terms or equations gets cancelled. Once they get cancelled, you just have a 2 up in front. So actually if you are integrating like this, dx I am including, the first term will be simply x, or 2x rather, because integration of dx is x, 2 is already there. So 2x. Now this I1 I am going to show you how to do this. Alright. So what we have to do, just try to understand. We have to do I equals to 2x minus I1. I am going to show you. There is a 3 also. Let me include 3 also. So we just have to integrate dx divided by 2 sin x plus cos x plus 3, and that has to be included in this equation. That will be our final equation. So this integration has to be done. Okay. Now you have to just learn and reactivate the previous exercise. Sin x was replaced by tan x by 2 term, remember? So now I am replacing the sin x by 2, tan x by 2 by 1 plus tan square x by 2. Cos x is 1 minus tan square x by 2 divided by 1 plus tan square x by 2, and plus 3 already there. Numerator we have already done. Now we are talking about the denominator. Okay, only in the first term we got, second term was having the denominator like this. So that's why we are dealing with this. So 1 plus tan square x by 2, I am taking the denominator right now, only the denominator part. So 1 plus tan square x by 2, this will be 4 tan x by 2 plus 1 minus tan square x by 2, and 3 will be multiplied by 1 plus tan square x by 2, because we have taken 1 plus tan square x by 2 as the LCM. So this is tan square x by 2. What do you see here? 3 tan square x by 2 minus tan square x by 2 will be what? It will be 2 tan square x by 2. This one. And this is 4 tan x by 2. 3 plus 1 is what? It will be 4. Now this 1 plus tan square x by 2 will go upstairs on the top. And this will form sec square x by 2. So let me write the final thing. This t was just for representation of tan x by 2. So let me write what do we get. Sec square x by 2 in the numerator, and 2 tan square x by 2 plus 4 tan x by 2 plus 4. This is what we are integrating right now. Now t you can take just 2 common here. Because if you take t equals to tan x by 2, dt will be sec square x by 2. Differentiation of x by 2 will be half. 2 will go on the left. So 2 dt will be equal to sec square x by 2 dx. This numerator will be simply 2 dt. To get 2 you can take common dt. And I was suggesting this denominator 2t square plus 4t plus 4. You can take 2 common, because 2 is already outside. If you take 2 outside, this 2 will get cancelled. You just have to deal with a simpler term, which is t square plus 2t plus 2. Ultimately you have to get rid of this 2, because you can't keep anything in front of the quadratic square term. So we have t square plus 2t plus 1 plus 1. I'm just writing 2 as 1 plus 1. The first 3 term will form t plus 1 whole square. The final term will be 1 square. So dx by x square plus a square integration we have to do, which is simply 1 by a. Tan inverse x by a, you already know that. X will take t plus 1, a will take as 1. So the integration will become like this. Tan inverse x by a, which is t plus 1 by 1. And what is t plus 1? What was t? T was tan x by 2, if you remember. T was tan x by 2. So you can just write tan inverse tan x by 2 plus constant of integration. This is your I1, remember? I told you I was equal to 2x minus 3 into whatever comes in I1. I1 was what? 2x. I'm writing the final answer now. 2x minus 3 whole term you can write. Tan inverse tan x by 2 plus 1 plus c. It's tan x by 2. There is a slight mistake. Okay. So this is your final answer with a tan x by 2 inside. So this is the way you are going to go about it. I showed you in away, but the same thing can be done when you take this differentiation or try to present 3 plus 2 cos x plus 4 sin x in the differentiation form of the denominator. That is also one way, and this is also one way which you are actually witnessing right now. Now 1 by p plus q tan x, and let's resolve it first. We have 1 by p plus q tan x, you can write sin x by cos x. This will give you 1 by this, you can just take LCM, p cos x plus q sin x. This cos x will go upstairs. It will be cos x divided by p into cos x plus q into sin x. So in this equation we have formed like this. We have a dx also. Now how to go about it? How to solve it? Now we can just write this cos x in the way of p cos x plus q sin x. So cos x can be written as a into p cos x plus sin x plus b into, what is the differentiation of the denominator? First denominator we have written. Now second we have to write the differentiation. It will be negative p sin x plus q sin x will be cos x. Now there are two terms. Cos x is just not a single term, okay? You can just call it as cos x plus 0. So you have to have a and b, two constant. Now multiply this a inside. I am right now multiplying it, and now I am multiplying the b inside. So you will get this as a cos and sin term, but you can just separate these two terms out. So I am taking the cos x term. When you take cos x outside, it will be ap plus qb. When you take this sin x outside, it will be qa minus bp. You can take this sin x outside. So you have this cos x equals to this term. Now you can equate these two. That is ap plus bq is equal to 1. There is no sin term on the left. So you can just say qa minus bp equals to 0. So you'll get qa equals to bp. That is a can be bp by q. This can be written in this first equation. In place of a, write bp by q. You already have a p here. Plus bq equals to 1. Now multiply these. Take the LCM. bp square. P and p will form b square. pp square plus bq square. In the denominator you have q, you can take it on the right. You can take b also common, b, and this will give you p square plus q square, that will go in the denominator. So b will be equal to q divided by p square plus q square. Now just put it here, whatever you got. It's bp by q. b can be written as q by p square plus q square. So it will be p by q, q by p square plus q square. Q gets cancelled, you will get p by p square plus q square, that is a. So these are two terms we got, a and b. So in this equation number 1, I am going to replace these two terms. So cos x has now become, now let's introduce the integration. It's a into p cos x plus q sin x. What is a? It's p by p square plus q square. What is inside? P cos x plus q sin x. What is the second term? It's b into, what is b you got? It's q by p square plus q square. And integration, it will be negative p sin x plus q cos x. Divided by what? Because denominator was already there. It was p cos x plus q sin x. You can write p cos x plus q sin x here. Here also you can write p cos x plus q sin x. So p cos x plus q sin x. Now these two gets cancelled. So if you call it as I1 and I2, the first term will be simply p square by p square plus q square into integration of dx will be simply x. The second term, q by p square plus q square, and you see p cos x plus q sin x already differentiated. We have already differentiated it, which is along with b, and that is what we have got in the numerator as well. Let me show you again. T, if you take p cos x plus q sin x, you will have a differentiation which will give you dt equals to dx equals to negative p sin x plus q cos x. Now this dx can't go on the right, so this part which I am showing is actually dt. So it will be dt by t, and this is already there. So dt by t, this is how I am showing you. It's simply ln modulus of t, or log base e modulus of t. What was t? T was taken as p cos x plus q sin x. So p cos x plus q sin x you can directly write. So the whole answer I am writing right now, the final answer, it is p by p square plus q square into x plus q by p square plus q square, which is the second term, along with the ln or log base C, modulus P cos x plus Q sin x, and then whole constant of integration, which is capital C. This is your final answer. This question was a very good question. I think you must try it by yourself once more. So we'll take this question in the next part. Till then, thank you so much and have a good one.